Good day, grade 8 learners. We are now on our quarter 2, week 3 of our lesson, which is all about illustrating and verifying a relation in a function. Our learning objectives would be 1. Illustrate a relation in a function. 2. Verify if a given relation is a function. 3. Determine dependent and independent variables. So let's have some recall. At the right corner of your screen, you will see there the map of region 3. We have to identify the coordinates where the specific place is located on the map. Example, Tarlac. Tarlac is located on the coordinates -2, 0. Now I will give you 10 seconds to locate for the other places. And your 10 seconds start now. On the screen, you will see there the coordinates of the other places. Now let's have some connections. Let's learn about mapping of elements. Let's read the first scenario. Mr. Reyes is the dealer of poultry eggs. He sells them at 210 pesos per tray for a large size of eggs. The following are the costs for each number of trays. We have the set A for the number of trays and set B for the cost in pesos. So in mapping of elements, we use arrows to represent the correspondence of the elements. So one tray costs 210 pesos, 2 trays cost 420 pesos, 3 trays cost 630 pesos, 4 trays cost 840 pesos, and 5 trays cost 1,050 pesos. Now let's have the guide question. How is the cost related to the number of trays? Any guess? Great! The answer is, the cost in pesos is related to the number of trays of eggs sold. Now let's have another example. Scenario number 2. Beverly is cleaning the house. Help her to complete the task by drawing an arrow from set A to set B. So we have the set A, the objects, and set B, the places in the house. So we can connect the cup to the kitchen, the pillow to the bedroom, toiletries to the comfort room, blankets to the bedroom also, plate to the kitchen, and bedsheet to the bedroom. Great! We have helped Beverly clean the house. So let's have some guide questions again. How are the quantities in set A related to the quantities in set B? Do you have any idea? Great! The objects in set A is related to its proper place in the house in set B. Very good, student. Now let's have the third example. Scenario number 3. Given a number 6 in set A, which are its factors in set B? So we have 6 in set A and the numbers in set B. So the factors of 6 are 1, 2, 3, and 6. Very good. Now let's have the guide questions. How do you relate the elements into two sets? So the answer? The given number in set A is related to its factors in set B. Good job! Now let's define now what relation is. Relation is the connection between the given two sets. And the domain are the elements in the first set. While on the other hand, the range are the elements in the second set. Now we have different classification of relation. We have the one-to-one relation, many-to-one relation, and the one-to-many relation. Let's differentiate each. One-to-one relation. Every element in the domain is mapped to a unique element in the range. While on many-to-one relation, two or more elements in the domain are mapped to only one element in the range. And lastly, one-to-many relation, each element in the domain is mapped to any two or more elements in the range. And we can also represent relations in different ways. We can use tables, ordered pairs, rule or equation, and the graph. Now let's have examples of each. Representation of relation using table. Let's go back to our scenario, the example before. Mr. Reyes is the dealer of poultry eggs. So the table that you will see later will show the cost of each number of trays of eggs and the cost in pesos presented horizontally and vertically. So we represent the number of trays by X and the cost in pesos by Y. Now let's represent the relation using an ordered pair. So based on the given example before, the following ordered pairs were derived. So we have the coordinates or the ordered pairs by the number of trays versus the total cost. Therefore, we have 1 and 210, 2 and 240, 3 and 630, 4 and 840, and 5 and 1050. Now let's try to represent the relation by rule or equation. So using the relationship of total cost and the number of tray of eggs, we have a rule. Total cost is equal to the cost per tray multiplied by the number of trays. In an equation, we can write it as y equals 210 times x, where y represents the range and x represents the domain. Now, let's have the representation of relation graphically. Below is the graphical representation of the relationship. So you can see there, the x-axis represents the number of trays, and the vertical line or the y-axis represents the cost per tray. Verifying if a given relation is a function. How do we know if a given relation is a function? Let's define first what function is. Function is a relation where no element in the domain is mapped or paired to more than one element in the range. So we can represent a function by ordered pair. So determine which of the following set of ordered pairs is a function. So we have A with ordered pairs 3, 5, 2, 7, 4, 6, -3, -5. And set B, we have 0, 1, -1, 2, 0, 3, and -2, 4. And for set C, we have -1, 2, 1, -2, and -2, 16. The other is 2, -16, -3, -54, 3, and 54, and many more. So for us To know if the given set is a function or not, let's solve for it. So given the set A is a function since there are no distinct ordered pairs having the same first element. Set B, on the other hand, is not a function since ordered pairs 0, 1 and 0, 3 have the same first element. Let's see if set C is a function or not. What are your guesses? So set C is an infinite set, but the pattern shows that there are no abscissas with the same value. Hence, set C is a function. Very good, students. So we must put in mind that the set of ordered pairs represent a function if no two distinct ordered pairs have the same abscissas or first element. Now we can also determine if the given graph is a function or not using what we call the vertical line test. There you can see the vertical line which is used to know if a given graph is a function or not. So in the first picture, the graph in A is a function since the vertical line touches the graph at exactly one point, even if it is moved to the right or to the left. Next, the graph in B, on the other hand, is not a function because if we examine the vertical line, it touches the graph more than once. You see, it touches 3 points at once. So it is not a function. Now, the graph C, examining the vertical line, it touches the graph once. Hence, the graph in C is a function. So I hope you're learning a lot, and using the vertical line test is very exciting, right? It's very useful. So we must put in mind again that vertical line test is a test that uses vertical line to check whether the relation expressed in graph is a function or not. If every vertical line intersects the graph not more than once, then the graph represents a function. Now, let's learn what dependent and independent variables are. So let's have some scenario. To earn some money, Robert cleans his neighbor's backyard for several hours during weekends. How much money did he earn? So the variables are the number of hours Robert works and the amount of money Robert earns. So let's have some guide questions. How do you know which variable is independent and which variable is dependent? So we must know the definition first. Independent variable are variable that will change by taking on different values. It changes independently from the word itself, and it is represented by the x variable or the x value. On the other hand, dependent variable are a variable that depends on the independent variable, represented by the y variable or the y value. Now in the scenario, which must happen first before the other occurs? And which variable controls the other? Which variable depends on the other? So on the scenario, We can say that the independent variable is the number of hours Robert works, and the dependent variable is the amount of money Robert earns. Therefore, Robert must work first before he earns money. Right? So I hope you learn a lot from our tutorial for this day. Again, thank you for watching. Don't forget to subscribe.